I'm Rainer, and this week we're going to be doing a problem that involves a mass hanging on a spring, and we're going to be trying to find the frequency of the mass as it oscillates on this spring. So in this problem, what happens is this: we've got a spring, and we attach a mass of mass m to it, and we let it just hang to the point where it's not accelerating up or down. And then after that, we slap it, and it bounces up and down, and we ask, what is that thing's frequency? So we're told the stretch distance that it originally falls down to before we slap it. And that's all we have. So let's see. Let's go ahead and start off by saying, okay, we want F. So I know when I'm talking about springs, I usually think omega is a little more useful. So maybe I say omega equals 2 pi f, and that will be on an equation sheet or anything like that. So if we can find omega, we can find f. And maybe I think about it a little more and I say, I also know omega equals the square root of k over m. And I know springs have spring constants, we have a mass, that should be a good direction to go. So maybe we say omega also equals square root of k over m. So now we just have to ask ourselves, what's k? Because once we know k, we can plug into here, get omega, plug into here and get f. So let's see. We know a little bit about the dynamics of this situation. So let's take the instant where it's just hanging there, because that's where we know information about the stretch distance. So let's draw a free body diagram. If we make the system the mass, and we make it at that instant where it's hanging there stationary, then I know I've got a weight force pulling down on the mass, and I've got a spring force pulling up on the mass. And those should be the only two forces acting on this mass. And so then I say, hey, when it's sitting here at rest, acceleration is 0. So if I sum those forces, they ought to sum up to 0. So if I sum forces in the y, I get spring force up. And I say positive will be the positive y direction, or up will be the positive y direction. And so I know that a spring force up is equal to k times the stretch distance. And I know the distance that this thing stretched is d. So that's the distance it went from rest length to length at equilibrium, where it's just sitting there. So d. So I know I have a force of kd pointing upwards, is what I mean by all that. And then I know I have a weight force pulling down, so I'm going to throw in a minus mg. And those sum up to m times acceleration in the y, which we just said was 0. And so I know if I just move this to the other side and divide by d, that k equals mg over d. So now we're pretty much done. We're just going to take this guy, throw him back here into this equation for omega. We're going to find omega in terms of this stuff, and then we'll plug it back up here and solve for f. So once we do that, that'll just be a little bit of algebra that I'll leave to you, and then we're done.